Good morning, everybody. Welcome back. Wanted to get some ed puzzles going for this week, just to kind of give you something a little different to help you practice. And I know that I've heard a lot of people saying that they like the ed puzzles, so something short and sweet that should help us with the understanding a little bit more. As always, remember, you can always pause these ed puzzles. You can always rewind them. And if it comes to a question where you don't know what the answer is, there's always an option to rewatch that part as well. So keep that in mind. Today we're going to be looking at lesson 28, which shows us another way that we can actually solve a system of equations. And the method that we're going to use is something called elimination. So when you think about the word elimination, it means that we're getting rid of something. And so systems of equations are set up this way because if we write them this way, we can actually eliminate something if we consider either adding or subtracting the equations from one another. So I'm going to take a second and write these two equations down for our first systems of equations today. We got 6x minus 5y equals 21, and 2x plus 5y equals negative 5. So if we have those two equations there, what you should see pretty quickly is that if we treat both of these equations as an addition problem, then something's going to happen right away. Minus 5y and plus 5y are going to cancel out. 6x plus 2x is 8x, and 21 plus negative 5, or 21 minus 5, is 16. If we bring our equal sign down, we actually get a really easy equation to solve. From here, we find that our x is going to be equal to 2. So now that we have one of our two coordinates, we'll put our x, y here, and we know that x is 2. Now we just have to figure out what y is. Well, if we already know our x, we can substitute it into either one of the equations, and by substituting it into the equation, we're going to figure out what our y equals. So you have the choice of which equation you're going to use. I'm just going to use the top equation because it's the first one that's there. So I'm going to take this top equation here and substitute the value 2 in for x. So we have 6 times 2, because remember, if there's no symbol between here, it means that we're multiplying, minus 5y equals 21. Well, 6 times 2 is 12, minus 5y equals 21. And we may get a whole number, we may not. That's okay either way. But we can solve this algebraically now. Our next step is going to be subtracting 12 from each side, which will give us negative 5y equals 9. And our last step here would be dividing by negative 5. So y is equal to 9 negative fifths, or negative 1 and 4 fifths, either one. I'm perfectly fine with you leaving it as an improper fraction when we get to questions like this. So negative 9 fifths. And this right here would be the solution to our system of equations. If we take this and we substitute it into this other equation here, our 2 and our negative 9 fifths, we know that it works for the first one because we actually solved for y. But let's test it out with the second equation and see if it works. So we've got 2 times 2 plus 5 times negative 9 fifths equals negative 5. And we want to test this out and see if it works. Well, we know that 2 times 2 is 4. That's easy enough. And 5 wholes times negative 9 fifths. Well, those two are going to cancel out to be 1s. And all of this together is just negative 9. So we have 4 plus negative 9 equals negative 5. And it just so happens that those two put together do equal negative 5. So that is going to be a solution to the second equation as well. So this process right here is called elimination. And you can use elimination to solve for one of the variables. Once you have what one of the variables is, you can substitute it into either one of the equations, and that'll be your solution for the other variable. So that's the key thing that I wanted to talk about today. Let's test that out with one or two more examples just to make sure that we are understanding that. You don't have to substitute in, by the way, to show your work each time. It's just something that some people like to do if they don't think that their answer is going to be correct. And you're welcome to use a calculator for that as well. So we'll look at example 2 here. Example 2, it's not going to be as easy to find something that eliminates this time, but we can manipulate one or both of the equations so that we can get to something that will cancel out. So I'm going to write these two equations here. We got negative 2x plus 7y equals 5, and we have 4x minus 2y equals 14. So if we're looking at those two equations there, can we multiply the top equation by anything so that our x's will cancel out? Hopefully you're noticing that if we take this whole equation and multiply it by 2, then our new equation is going to be negative 4x plus 14y equals 10. Now, those two equations actually represent the same thing. The y-intercept is going to be the same. The slope is going to be the same. It's just that we took all of our values and multiplied it by 2. Nothing changes there, though, so we can actually do that. But we'll keep this other equation exactly the same, how it is. So we've got 4x minus 2y equals 14. And now our x's will cancel. 14y minus 2y. Well, 14 minus 2 is 12. And we've got 10 plus 14. 10 plus 14 is 24. Once again, we get to a really easy equation that we can solve. When we divide both sides by 12, we get that y is equal to 2. Wow, kind of convenient considering the last question, x was equal to 2. So we know that our solution to a system of equations is a point. It's where those two lines intersect with each other. And this time we know that our y is equal to 2. We're trying to figure out what x is. If we know that y is 2, we can substitute it into either one of these equations. And I always like to pick the top one. That's completely up to you which one you pick, though. So we have the equation negative 2x plus 7 times 2, because now we know that y equals 2, equals 5. Now from here, 7 times 2 is 14, and we have negative 2x plus that 14. So our next step here is going to be subtracting 14 from each side. So this is an algebraic approach to solving this as well. We subtract 14 to cancel those out. We get negative 2x equals negative 9. And then finally from there, we're going to divide by negative 2 to get that x is equal to, negative divided by negative, be careful there. That's going to give us a positive solution, and that's going to give us 9/2. Or if you want to write it as a mixed number, 4.5. Either one of those is fine. Because it looks a little neater, I'll put 4.5 here since I'm not going to substitute it this time. And that's going to be our solution. We can even check real quick. 4 times 4.5, well, 4 times 4 is 16. Half of 4, that'd be 18. Minus 4 equals 14. It substitutes into that second equation and works there as well. So our second method that we're going to use there is manipulating one equation so that we get something that cancels. So there's just one more example that I wanted to talk about, and that's going to be something like example 3. Example 3, it's not as easy to just manipulate one equation. So when we get to something like this, you might want to try manipulating both equations so that you can get something to cancel out. So we've got the equation 7x minus 5y equals negative 2, and 3x minus 3y equals 7. When we get to two equations like this, where it's not going to be, they don't share any common factors, there's nothing that we can multiply one by, we can multiply both. So we could either multiply our 7, or our top line by 3, and our bottom one by 5 or 7. I'm going to use 3 and 5. So what I mean by that, if I take this whole top row and I multiply it by 3, I'm going to have 21x minus 15y equals negative 6. Now, because I changed that top one, I can now see, I can multiply the bottom by something so that my 3 either gets to negative 21 or my negative 3 gets to positive 15. Well, because I want to get it to a negative, I'm going to multiply by negative 5. So I'm going to try to cancel out my y's here. That's going to give me negative 15x plus 15y equals negative 5 times 7, which is negative 35. Now we can cancel those two things out. When they cancel, you have 21x minus 15x, that's going to be 6x, equals negative 6 plus negative 35. So negative 6 plus negative 35 is going to give us negative 41. And from here, divide each side by 6. And that'll tell you that x is equal to negative 6 and 5/6, or we can just call it negative 41/6. So that's not a really nice value to work with there, but we can still use that as something in either one of our equations to get to an answer. I'm actually going to end this video with this, but I'm going to put a question in now to see if you can use another method to figure out what x and y are going to be. You can also test this out on Desmos to see where these two are going to intersect. So my question is actually going to be, for this one, what is y going to equal? So we did an example of each, and we can kind of pick out different ways that may be a little bit easier for us to work with. What you might want to try is multiply this by negative 7 instead and see if you get a whole number for your y value. If you get a whole number for your y value, it might be a little bit easier finding values for your x that are going to work. Just something to think about. What I'd like you guys to do, though, is take a look at a couple of the exercises here, just to find the solution for exercise 1, 2, and 3. So just 3 more examples, using elimination to determine whether you have the right answers or not. Feel free to send me emails with questions if you're stuck on anything, and feel free to schedule a Google Meet with me as well. We'll be talking about some of these examples during our Google Meet at 10 o'clock as well. So I hope to see you guys there. Good luck with this, and come with questions. Later.